Hi everyone, this is the second video for section 7.3 on multiplying and dividing decimals. So we're going to talk about the common algorithm for multiplying decimals really quick. Again, this is something that you all know how to do, so we're not going to spend too much time on it. So the first thing we do whenever we multiply decimals, so I'm going to do kind of a motivating example while we go through this. So the first thing we do is line up the numbers, write the numbers vertically, like normal, lining up the rightmost digits. So if we're multiplying 2.6 and 3.2, we just line them up so that everything is aligned to the right. Right, if you're used to working on like any word processor like Microsoft Word, you just line everything up to the right. Yeah, like you would do in any word processor. So then we just multiply these as whole numbers. So we do the multiplication 26 times 32 here. So 26 times 2 is 52. Yeah, so this is 26 times 2 is 52. Then we have our placeholder. Let me write this a little bit. So 52, and then we have a placeholder, and then 26 times 3 is 78. So then we would add this, and we get 2, 3, carry a 1, so we get 832 whenever we multiply this as whole numbers. Then we count the number of digits to the right of the decimal place and to the right of the decimal point in each of the two factors. Suppose this is m and n digits. So 2.6, m equals 1. We have one digit to the right of the decimal point, and 3.2, n equals 1, because 2 is the only digit to the right of the decimal point. So then we insert the decimal point in the product so that there are m plus n digits to the right of the decimal point. So m is 1 and n is 1, which tells us that m plus n is 2. So we put the decimal right there, and our answer is 8.32. And that's the common algorithm that most of us use to multiply decimals. So one way to check if this decimal place is correct is to use estimation, which we talked about in chapter 4. So 2.6 and 3.2, the example that we just did, these are both numbers that are really close to 3. So we should expect that their product should be close to 9. So after multiplying, if we get this 832 and we don't know where to put the decimal point, you can use that this should be an answer fairly close to 9 to help reaffirm that you should put the decimal place right after the 8 so that it's 8 point something, because that's the only way we're going to get pretty close to 9. Okay, so this is the common algorithm, what we know how to do, a way to check if we think we're doing it right. But one thing that may not make intuitive sense to your students is why we add the number of decimal places in step C, in D, why we do m plus n. And so this is why we did all of these motivating examples in the last video, where we saw that a tenth times a tenth is 100th. And yeah, we used fractions to see that a tenth and a tenth is 100th. We used base blocks to see that whenever you had one base block represent 1 in your factor, that it changes in your product to preserve that 1 times 1 equals 1. Or just thinking about what it means to multiply fractions, or just to multiply fractions, which is what it means to multiply decimals, is that essentially we are multiplying a part times a part. So we are multiplying a part times a part. And remember that whenever we're doing this in decimal places, it's the same as with fractions. So this gives a piece of a part. Which is a smaller amount. So right, we're getting a piece of a part, which is going to be smaller, but also a tenth and a tenth of a tenth is 100th, right? When we take a tenth and divide it into 10, we get those smaller pieces, and we only care about one of them. So this is why this all works. Okay, so we have talked about our multiplication models and our multiplication algorithms. So now we're going to transition to talking about division models. So again, I know that the book doesn't talk about models nearly as much as I do, but I really like to show you the models just to kind of motivate why the algorithms work the way they do. So we're going to start talking about division by talking about division models. So we are going to, again, start with base 10 blocks, and we want to divide 6.12 divided by 3. Okay, and remember, we had an example similar to this whenever we divided fractions, whenever we started to divide fractions. And if we're dividing by a whole number, we can think of this as using a partition model. So partition model, meaning that we can represent 6.12 using base blocks and then separate it into 3 groups, partition it into 3 groups. So just like before, we have our hundredth as our smallest place value. So we are going to use a 100 block, which is a flat, to represent 1. So we have a partition model where our flat represents 1. Okay, so we now are going to write 6.12 using base blocks. So we're going to have 6 of these flats. And kind of because I know I'm gonna divide it into three pieces. I'm doing it in columns of 3. Then we have 1 long. Okay, and then we have 1 long and 2 units. Okay, so we want to divide this into 3 pieces, into 3 different groups to partition it. And just like with our regrouping, we start doing that with the units. So I cannot break up these units into 3 different groups because I only have 2 of them. So what I'm going to do is I am going to regroup this long into 10 different, into 10 units. Okay, and so I'm going to do that. So then I'm going to separate this into 3 different groups. So now that I've broke up my long into 10 units, I have 12 units total. So I can think about one group of them. So we're going to split this into groups of 4. I did this wrong. There should have only been 2 right there. Okay, so now we're going to split them into groups of 4. So we have one group here, and one group here, and one group here. Okay, so we have these 4 groups, and I'm also going, so now we've separated the units into 3 groups. We don't have any more longs, so now we can split our flats into 3 groups. So I'm going to kind of just associate them with one of the groups we already have. And well, these over here. They go together as everything that's left. Okay, so now we have 3 groups, and in each group, has 2 flats and 4 units, right? Each group has 2 flats and 4 units. So that tells us that 6.12 divided by 3 is a flat represents 1, and units represent our hundredths. So this is 2.04, 2 and 4 hundredths. Okay. So this is how we use a model to show division by a whole number. So if we're dividing by a whole number, we just use base blocks to represent our total amount and then partition it into that many groups. Okay, so this is a partition model. We can use a partition model whenever we're dividing by a whole number. However, that changes a little bit whenever we are trying to do a whole number divided by a decimal. So in this case, we are going to use kind of a repeated subtraction model. Yeah, we're going to use this repeated subtraction model. So we're going to represent 2 with a flat. So in this case, we're also going to have a flat represents 1. And I will say, whenever you're filling out anything written like on an exam, please make sure that your flat is significantly bigger than your units, just to see. I mean, they're both like little squares, so just make sure that your units and your flats are have a sufficient difference in size in order to tell them apart. Okay, so we have that this flat represents 1. So we are going to have 2 represented by 2 of these flats. And we want to take away half of it at a time. So we want to make groups of size 1/2. Remember that we can think of this division as how many groups of size 0.5 or 1/2 can I make out of 2. So we're going to make groups of size 1/2. So we have this flat that represents 1. So first, we can have this group represent 1/2. So we're going to have 1 group. And then we have this other group here. So we have now 2 groups. And then we go over to the other flat. And so right now we have this group that we've accounted for. And then we have 1 group left that we need to take away in order to completely account for all of the picture. So we made 4 groups. So out of 2, well, we can make 4 groups of size. Make 2 groups of size 1/2, which is 0.5. So we can make, 4 groups. We can make 4 groups of size 0.5 out of 2. So that tells us that 2 divided by 0.5 is 4. Okay, so these are some examples of division models, and most of the times our models are easier when one of the numbers is a whole number. Multiplication is pretty simple with two different decimals, but division is much easier when you have a whole number to divide by or divide from as either your dividend or your divisor. So these are the only division models we're going to talk about. And so in the next video, we'll start talking about division algorithms.